Hey guys, in this video I'm going to be doing a build overview of the FD120 frame. This is a 120 size frame for 2.5 inch props, and I will just quickly go over how I put this together. And I'm not going to be doing a full build in this because if you want to see how this is built, just look at one of my previous micro builds and it's going to be pretty much the same. But I'll just give you a quick sort of overview of how this goes together. Basically, you start off with your power cube, which is your 4-in-1 ESC and flight controller combo. This happens to be the Freebie F4 fly tower. It's got the F4 chip with the Omnibus F4 flight controller and OSD, Betaflight OSD. These have 20 amp 4-in-1 ESC, so I put that in there, soldered on my motor wires, and I have them going underneath. They go this way and then around the back, and then they solder to the underside of the ESCs there. So all the wires are stuffed underneath. Instead of coming in through the side, it makes this part of the build look a lot cleaner. And then I'm using rubber bands here to secure my battery. And that's another unique feature about this frame, is that all the screws, except for the motor screws, on the bottom part here where the battery goes are countersunk. So there's a screw here and a screw here that holds this little plastic standoff here that holds the side plates on, and you got the 4 screws here that go into the flight controller stack. Those are all countersunk, so we get a very nice flat look on this. So I'm not using any foam here because there's no screws to protect against, so I'm just putting some grippy rubber stuff here to basically grip the battery, and then the rubber bands also grip the battery as well, and that holds it pretty well. But you can see it's a pretty unique design. You got these two side plates here. They're vertical. I think a lot of frames are kind of going this route for some reason. I'm not exactly sure why. But you know, it does seem to provide pretty good protection for the camera. And as you see, I have the micro Swift in there, and I think in any type of frontal impact here, these plates here are going to take a lot of that force. So I'm pretty confident that the camera should be pretty well protected. The bottom plate here is a 3mm plate. It's 3K carbon. Very stiff frame. Yeah, this is extremely stiff. So I'm pretty confident it's going to hold up really well in a crash. It's built like a tank. Overall, this thing weighs actually quite a bit with all the components. 83 grams, I believe, all up with the props. And it's probably due to these motors here. These are the Spintech. Okay, so get that to focus. So these are the new Spintech motors, 1106, 8000 kV. So these are have a lot of power. Even on these RotorX 2535 props, it's going to be just crazy power. Now for the camera mounting, this frame is not actually built for the Micro Swift. I just have it kind of stuffed in there. It's kind of sandwiched in between this top standoff right here and the bottom one right there. So you can see it's kind of in between those two, and it just happens to be just the right width for this. It's about 21mm, 22mm, so it just fits in there and it doesn't move at all. It's kind of sandwiched. So the frame's actually made for an all-in-one camera, and it has a little TPU camera mount that screws into this little side screw here. Unfortunately, it doesn't line up right with the Micro Swift, so I can't use a screw to mount the Micro Swift, but it's not going to be going anywhere. It's in there pretty good. And then I have that camera and also the VTX03 plugged into the flight controller. It's actually soldered in directly using the video in and video out, and so I can use the onboard OSD, so that's going to be kind of nice. And then for the receiver, I'm just using a FlySky FS8S for my Turnigy Evolution. And then for the battery connector, I swapped out the JST connector for an XT30, because these motors are going to be drawing a ton of power, and if you don't switch that connector, the ESCs are going to reset. They're going to brown out, so you should be aware of that. Anyway, not a whole lot to this build. Only difference is that this is using an F4 Omnibus board instead of the F3. So the one thing you do have to be aware of is that if you're using an iBus receiver, like for example, I'm using an iBus receiver, you have to use RX1 or UART1 instead of UART3, because UART3 is inverted, and iBus is not inverted, and there's no way to turn that off. So these are the receiver connections here. I mean, I obviously have the ground and the power, and this third one is RX3 on UART3 or receive 3 on UART3, and I'm instead of using receive 1 on UART1 instead. So that's something to be aware of. It's only this particular board that this is unusual about. Everything else is going to be the same as my Omnibus F3 build. So if you want to see what this config looks like, we'll go and look at the I think it's the Squirt 100 video. That's I think it's also an Omnibus F3 board as well. Anyway, go ahead and I'll roll some flight footage here for you. Let me know if you guys have any questions about this build, and I'll talk to you guys in the next video. So this is just a little bit of line of sight footage that I shot from my hat cam. This is from a GoPro Session 5. Sorry about the video quality. It's pretty dark out, cloudy, and the GoPro doesn't handle these lighting conditions all that well. I had to brighten up the image by about 25% just to be able to see anything. But anyway, in terms of the flight characteristics, this little micro really has a ton of power with those 1106 motors. I'm barely on the throttle, and it just wants to really move a lot. And I'm realizing that the PIDs I had from, I think this was from a different build. I think it was 1104 7500 kV motor build. You know, the PIDs are way too high. I'm getting quite a few oscillations. So I'm after I land this, I'm going to actually change the PIDs and lower. I think it's the P and D gains. And then in the FPV, you'll see that flies pretty well.